Hello guys, so today we'll be doing question 167 of LeetCode, which is 2 sum 2. Input array is sorted. So the question is, given a one indexed array of integers numbers that is already sorted in non-decreasing order, which pretty much means smallest to largest, find two numbers such that they add up to a specific target number. Let these two numbers be number index 1 and numbers index 2, where 1 is smaller than or equal to index 1 and which is smaller than index 2, which is smaller than or equal to numbers.length. So return the indices of the two numbers index 1 and index 2 added by 1 as an integer array, index 1, index 2 of length 2. The tests are generated such that there is an exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Input numbers is equal to 2, 7, 11, 15. Target is 9. Output is 1 and 2. The sum of 2 and 7 is 9. Therefore, index 1 is equal to 1, index 2. We return 1, 2. So pretty much, it's the index position plus 1 or the actual array position. So first number, second number. Input numbers 2, 3, 4. Target is 6. Output is 1 and 3. The sum of 2 and 4 is 6. Therefore, index 1 is index 2 is 3. We return 1 is 3. So this is pretty much the same as the 2 sum. We can either use a brute force by doing double for loop, which is time complexity omega squared, or you can store the past elements in a map or object and use those to calculate the remainder and get the current number and calculate the remainder and check if it's an object and return the object value and the current number, which was O(n) complexity. So let me walk you through the quick solution, which is easy to explain. So what we do is we create a for loop. So for let I is equal to 0, long as I smaller than numbers dot length, then I plus plus, then for let j is equal to I, for let j is equal to I plus 1, long as j smaller than numbers dot length, j plus plus, then if numbers I plus numbers j is equal to target, then we return as an array I plus 1 and j plus 1. Now let's run that. As you can see, this passes. Now let's submit. And it does pass, but as you can see, the time complexity is very slow. And there is a better way of doing this, which is with a map and one for loop, which is a time complexity of O(n). So let me walk you through on the whiteboard. So the first thing we do is we create a map. So map. This map will store the number and the in position of the number as a key and the in position of the number as a variable, as a value. So let's say the index. What was the example? The example was 2, 7, 11, 15. 2, 3, 4 is shorter, so 2, 3, 4. So 2, 3, 4 is the array, and the target is 6. So we go through 2. No, so we loop through the array first. So I is equal to 0. We get the complement, which is target. So complement. Let's go save it somewhere else. I is 0, complement is equal to target, so which is 6, minus I, which is 4. Now we check if 4 is in the map, which is not. So therefore we push 2 in the map with the index value. So we push 2. Let's go here. 2 with index value of 0. Then we're now I equals 1. So now we're at 3. Now we get a complement. So 6 minus 3 is equal to 3. So the complement is 3. Is 3 in the map? No. So yet we haven't got the solution. So we add 3 to the map. So now map is 3 and 1 as well. Now where I is equal to 2, which is 4. So complement is 6 minus 4, which is equal to 2. Do we have 2 in the map? We do, as you can see up here, 2. So we return as an array the current index value plus 1, which is 2 plus 1, which is 3, and then we return the 2's value, so map.get 2, which is 0, 3 and 0. You can do either order, 0 or 3. Let me show you how to do this in code. So we create a map, let map is equal to new map. Now we create a for loop, so for let I is equal to 0, with I smaller than numbers dot length I plus plus. Okay. Now we check. We get complement. So complement is equal to target minus numbers I. Now if map dot has complement, then we have a solution. So we return as an array map dot get complement. Just in case it doesn't matter, we'll put the first digit, the first number we found first, and then we'll put the current index, which is I. Remember, we've got to add 1 to each, so I plus 1, and map dot complement plus 1. Else, if it's not in there, then we set it. So map dot set. We set complement. Sorry, not complement. We set the current value, so numbers I with I. Now let's run that, see if that passes. It does. Let's submit. Perfect. As you can see, this is the fastest time complexity. It's a time complexity of O(n), as we're only looping through the array once, and the space complexity of O(n), as we're also storing the array worst case. Thanks for watching.